Hello students, in this video we'll discuss how to solve homogeneous differential equations. A homogeneous differential equation is one of the form mxy dx plus nxy dy equals 0, where m of lambda x lambda y equals lambda to the k m of x y, and n of lambda x lambda y is lambda to the k n of xy for some k. All this condition means is that the powers of x and y are the same cumulatively throughout the entire equation. So let's see an example of this. Let's consider x minus 2y dx plus 2x plus y dy equals 0. This equation is homogeneous of degree 1. The k in the relationship in the previous sentence is called the degree of homogeneity. So this k is the degree of homogeneity. So what will happen over here is my m of xy will be x minus 2y, and my n of x and y will be 2x plus y. And now if I plug lambda in for x and y, we'll see that m of lambda x lambda y will be lambda x minus 2 lambda y, and there's a common factor of lambda, so this will be lambda times x minus 2y. In other words, I can pull out one factor of lambda from m if I scale both the x and the y by lambda. And the exact same reasoning will show that n is homogeneous of degree 1 as well. So, in order to solve homogeneous differential equations, we'll make the following substitution. And this will be true for all homogeneous differential equations. We will let y be equal to vx. So this is the substitution that's made for all homogeneous differential equations if it's of degree 1, if it's of degree 2, of any degree. So this is always the substitution for homogeneous equations. Now, once we have that v is equal to y over x, or y is equal to v times x, we can compute the differential. Then dy will be v dx plus x dv by the product rule. So let's fill in that substitution into our equation. So we'll have an x minus 2y, but now we're going to replace y with vx. So the y in our equation is now a vx. That's my substitution. This will be my dx plus 2x plus y. We know that y is now vx. That's my substitution. And now I replace dy with v dx plus x dv equals 0. And now we gather all the like terms. So what terms have dx's in them? Well, the dx terms will have an x minus 2vx. Those are the first dx terms. The second vx terms will have a 2xv, so that'd be a plus 2xv, and then a plus v squared x dx. And then the dv terms will be the following. I will have a 2x squared, so this will be plus 2x squared, plus v times x squared dv equals 0. And we have some cancellation over here. And I can rewrite our equation in the following form. It will be x times the quantity 1 plus v squared dx plus x squared times the quantity 2 plus v dv. And now we can divide and turn this into a separable equation. So if I divide the equation by 1 over x squared and also by 1 plus v squared to both sides, I will see that my equation will become dx over x plus 2 plus v over 1 plus v squared dv equals 0. Now for this separable equation, I'll simply just integrate. I'll break the second term into two parts. So now we will integrate this, and I will have the natural log of x for the x antiderivative. Then I will have a plus 2 tangent inverse of v from this term over here. And then I will have to do the integral of v over 1 plus v squared dv, which I can do by putting a 2 on the top of the v and a 1/2 out in front. And then it becomes the logarithm of 1 plus v squared 1/2. So this will be plus 1/2 the natural log of 1 plus v squared equals c. And the final step in the procedure is to replace v with what v is equal to. So if y is equal to v times x, then y over x is equal to v. So the solution of our differential equation is the natural log of x plus 2 tangent inverse of y over x, that's what v is equal to, plus 1/2 natural log of 1 plus y over x squared equals c. And there is the solution to the differential equation. So the homogeneous substitution that we've introduced will take our homogeneous differential equation and turn it into a separable equation. So y equals vx turns homogeneous into separable. Thank you very much.